Alright, now the second questions for charge in a uniform electric field. The figure below shows a section of the deflection system of a cathode ray oscilloscope. An electron traveling at a speed of 1.5 exponent 7 meter per second enters the space between two parallel metal plates 60 millimeter long. It's long, not apart. It's 60 millimeter long, not 60 millimeter apart. It's different meaning. Yeah. So this 60 millimeter long means the length of the plate instead of the separation of the plate. Yeah. Here in diagram it gives you the separation is 20 millimeter. Okay, the electric field between the plate is 4 exponent 3. Okay, this information actually is not necessary because it already give you the, you see the potential difference already give you, the separation D also give you. So this one actually you can find out yourself. But since it gives you this information, you can directly use this value. Yeah. Never mind. Later on we will see. Copy the figure and sketch the path of the electron in between the plates and after emerging from the space between the plates. Okay, so how will the electron move in between the plate and also after emerging from the plate? Okay, so he asked you to copy the figure. So I have copied the figure. Okay, which one is a positive plate? Which one is a positive plate? Okay, let us start. The positive plate should be at a higher potential. You see, this 80 volt, positive 80 volt means this is a positive plate. Okay, positive plate. This one should be a positive plate. And then 0 volt normally is the negative plate. 0 volt is the negative plate. Normally we take the higher potential. Normally we take the, the higher potential as the positive plate, the lower potential like 0 or negative volt. Okay, the lower potential as the negative plate. Okay, so I have drawn positive plate above, negative plate below. Okay, positive plate is higher potential, negative plate is lower potential. Okay, I have written down here. Now, so electric field must originate from positive plate, go to negative plate. Electric field must downward. Downward. So this is what kind of charge? You must know what kind of charge is this. The test charge. What I mean is the test charge is what kind of charge? Is a positive charge or negative charge? Be careful of that. This one is an electron. Electron is a negative test charge. Okay, electron charge and the mass of electron. You use the electron charge 1.6 exponent negative 19 and also mass of electron 9.11 exponent negative 31. You can get this value all from the list of constants. Okay, so this is the test charge. Test charge is the one that always moving around. Yeah, this is the test charge. So there's electron here. Okay, electron going to enter the plates. So where do you think the electron will be deflected? You see, this question, does it give any hints of gravitational force, the weight of electron? Did it specify the mass of electron? I know I can get the mass of electron from list of constant, but it doesn't give a hint that this question required to consider about gravitational force. Okay, or consider the weight of the electron. No, this question doesn't give you that hint. The question that gives you the hint that need to consider the weight of electron is he will specify the mass of electron, mass of the charge. Maybe it's not electron, maybe it's other charge. He will give you. I have explained that in the questions one. Yeah, question one before I explained. Question that require you to consider the weight of the charge is he will give something like this: test charge with certain mass. If that case, the total force is not just the electric force, it's including the weight of the charge or gravitational force of the charge. Okay, so back to our questions. These questions doesn't give you any hint of gravitational force. No mass is given. Okay, so the gravitational force is neglected. We can say the weight of electron is we can say ignored. Okay, ignored. So what force? So left with what force acting on the electron when passing through between the plate? Only the electric force. Only the electric force, because electron will be attracted to the positive plate by the electric force. Why you have electric force? Because you have electric field. You understand that? Because back to our main formula. Why we have electric force? Because we have electric field. Because we have electric field. So the charge inside the electric field will experience electric force. Understand? The charge inside the electric field will experience an electric force. So the only force acting on the charge is the electric force. Okay. So okay. So what happened in between the plate? The electron will be attracted to the positive plate. So let us sketch. Yeah, let us sketch. Yeah. So it will go this way. Okay. It will go. It will not move straight. Yeah, because there's no gravitational force. There's only electric force. So it will being attracted. Okay, hold on a second. Yeah, so it will be attracted to the positive plate. That's it. Okay. Attracted to the positive plate, and then in between the plate you have electric force. But when going out of the plate, there's no more electric force. There's no more electric force. Why? Because no more electric field. Outside of the plate, you have no more electric field. When zero electric field, so the force also becomes zero, isn't it? Outside the plate, electric field is zero. Electric field is zero, F0. Okay. In between the plate, you have electric field. Outside the electric field, electric field is zero. So force also zero. So what happened to the charge? Will it move? Still it move in projectile motion? No. Outside is a straight line. Outside is a straight line. Outside is a straight line. Okay. So in between the plate is a parabolic path, like a trajectory or projectile motion. Outside the plate is a linear motion. Linear motion, straight line. Okay. Inside parabolic, outside straight line. Okay, that's it. You must draw straight line. If you still draw parabolic, then you are wrong. Outside you must be straight. Maybe I'm not straightforward. Not straight enough. So I need to be really straight. Really straight. Like that. Really straight. Can you see the difference? This is curve. Here is a curved line. Here is a straight line. Remember that. Okay, outside is a straight line. Now, enough of that. Okay, so let us continue. Do the calculation. Okay, sketch the. So you see, this question, you sketch the path. You have two parts. You have two parts. Be careful, not only between the plate. Sketch a path between the plate and also after emerging from the plate. So you have two parts. You have one, you have two. So don't just draw between the plate. You also have another parts. So you must have two. Have one parts and then the two parts. Okay, remember that. Now, after finishing that, find the acceleration of the electron between the plate. Okay, so acceleration of the electron. So we know that in between the plate, you have the electric force. Okay, I see the negative test charge. The force is opposite to electric field. Do you see that? When the test charge is negative, the force and electric field opposite direction. Okay, so why this charge have acceleration? Because of electric force. This electric force, okay, based on the Newton's second law, total F equal to ma. So the resultant force, this one, okay, because in between the plate, total force equal to Fe. You see that? In between the plate, the electric force acting on the electron. So you have resultant force. When you have resultant force, you have acceleration. Okay, acceleration. But this force is only in the y components. This resultant force is only on the y component. Fe. That's why it only affect the y acceleration. Okay. For the acceleration in x component is still 0. Okay, because this force only act in the y component. So in the x component, in fact, the resultant Fx is 0. There's no resultant force in the x component because maybe we consider this one as a vacuum. Vacuum, no air resistance. So in the x component has no force at all. X component has no resultant force. So acceleration x is also 0. Okay, let us find out this acceleration in y component. Fe equal to ma. All right. And then Fe is equal to EE because Fe equal to Q naught E. Yeah, F equal to Q naught E. So our charge is an electron charge. Just electron charge. So that's why we put electron charge times electric field times Ma. Okay. So find the Ay. Ay is electron times electric field divided by mass of electron. So how to find? Now I need to find the electric field. It's given already actually. It's given already, but it's given in the questions. But if the question already gives you the potential difference and the distance, you can actually find from there also. Yeah, let us find out. Okay, what's the electric field strength? So electric field strength is actually high potential minus low potential, 80 minus 0 over the separation between them is 20 millimeter, milli exponent negative 3 meter. Okay, so what do you get? You will get the value, you will get the value 4 exponent 3, 4 exponent 3 volt per meter. Okay, because top is the volt, yeah, volt per meter. So is it the same? Yeah, it's the same as the value given. You see that? It's the same as the value given. Okay, so we can use this value here. Now let's calculate. Let's continue. The electron charge is a 1.6 exponent negative 19, and then the electric field is a 4 exponent 3. Okay, 4 exponent 3, and then the mass of electron is a 9.11 exponent negative 31. 9.11 exponent negative 31. So what is our acceleration? Our acceleration will become, our acceleration will become 7.025 exponent 14. Okay, that's our acceleration in y component. Okay, that's it. Acceleration. So yeah. So now better rub off certain information here to make not so messy. Yeah. So okay. Yeah. Yeah. So let's rub off everything here. Now, no need this one. Okay. Now, okay. Now, lastly, determine the velocity. Just now I already got the acceleration. Okay, acceleration. I already got the acceleration. Now the question asks for velocity. Velocity. So if you look at the when it emerges from the space between, that means velocity final. Yeah, when emerges. As you can see, the question asks for velocity emerges. That means velocity over here. Velocity here. This velocity is 2-dimension. This is a projectile motion. Projectile motion, like you learned in the first semester about projectile motion. This velocity has x component and y component, vx and vy. Then you need to find the vx and vy, and then do the Pythagoras theorem, and then find the direction tangent theta, isn't it? So this has two components. This has two components, x and y. Yeah, x and y. So as usual, just now as I told you, in the x component, there's no force. Yeah, so ax is 0. Okay, ax is 0. But ay you got just now, ay is this one 7.025. Okay, that's ay written here. Okay, that's ay. You see the direction. The direction acceleration is going upward. So your acceleration, remember, your acceleration also need to be positive. Your acceleration is positive because your acceleration is going upward. Acceleration going upward. Okay, at ax0, ay is this. So how about the ux, initial x component velocity? Ux is this lah. This is the ux because this is the velocity in x component. Okay, this this is actually the initial velocity. U is equal to ux. Okay, is equal to ux. This is like horizontal projectile. You understand? This is like horizontal projectile. What do you learn about horizontal projectile? Horizontal projectile, the uy is 0. Still remember uy is 0? Horizontal projectile, it only has velocity in x component. Okay? That's why our ux is u itself, 1.5 exponent 7. I written down here. Uy is 0. You see that? Uy is 0, horizontal projectile. Okay? Ux is this, uy is 0, horizontal projectile. So, okay, ax, the force only in y component, so the fay. So now, yeah, sx is equal to the 60 millimeter just now, yeah? Look at the diagram, yeah? Look at the diagram. See that? You see that? This is the, you know, the electron travel along the plate, isn't it? There's a cat enter my house, yeah, suddenly, yeah, scared me off. All right, so there's the plate, the length of the plate is 60 millimeter. So this is the horizontal displacement, which is 60 millimeter. Okay, 60 millimeter. Okay, there's sx. And then we can continue. Now we want to find the velocity, isn't it? Want to find velocity. First, we already got the velocity in x component. The final velocity in x component is equal to the initial velocity in x component because ax0, no acceleration. So the u is always constant. U is always, u is always constant. Ux is always constant. That's why final velocity in x is the same as initial, 1.5 exponent 7. Okay, so the only thing we need to find is vy. We need to find vy before we can find resultant. Okay, now first of all, to do the y, we need to find the time first. We know that both time is the same, isn't it? Both have the same time. Tx must be equal to Ty. That's the principle, the most important thing in projectile motion. You know, both components happen simultaneously. So the time for x will be the same as time for y because both happen at the same time. Okay? So time x equal to time y. So first of all, from the x component, we find the time first. Yeah? Find how much time does the charge move from one end to the other end. So we can find the total time here. Okay? Using the x component, find the time that the charge travel from one end to the other end along 60 millimeter. How long it takes to travel 60 millimeter. Okay? Now, okay, so let's find out the time. Okay, first of all, very simple. Ax is 0, ax0, so we can cut off the ax here. Okay, 0. So, yeah. So this one, just put in the value 60 millimeter, milli is -3. Change to meter already. And then ux is the 1.5 exponent 7. 1.5 exponent 7 time. So we got the time. All right, we got the time. So okay, so yeah, so okay, time is equal to half AT square already gone. Half AT square already gone. So what's the time? So the time I got is 4 exponent -9 second. That's the time. So this time can be used in the y component. Can be used in the y component to get the final Vy velocity. So okay, V equal to U plus AT, because I already have U, I already have A, I already have T. I want to find V, so V equal to U plus AT. So first of all, we know that Uy is 0 because it's horizontal projectile. You know, horizontal projectile, because it enter without angle. You see, the charge, it enter with horizontally. It enter horizontally. If the charge enter with an angle, then you have cos theta already. It's not horizontal projectile anymore. You have cos theta and sin theta. But this charge enter horizontally without any angle. Without any angle, so it's a horizontal projectile. So it doesn't have initial y velocity. Okay? That's why Uy 0. Okay, so we just add in this Ay is positive. Ay is positive because it's directed upward. Because force is upward. Force is upward. So Ay, acceleration follow the force. Acceleration follow the force, also upward. So our Ay is upward. So it's that's why our Ay is positive. Okay, Ay is positive. Now let's find out. Let's find out the answer. Vy is equal to Ay. What is Ay? Ay is positive 7.2025 exponent 14. What's the time? The time is this one lah. 4 exponent -9. Okay. So in the end, we will get Vy equal to 2.81 exponent 6 meter per second. This is value positive. Have we finished the question? Not yet. This is just the y velocity. You haven't combined with the x velocity to find the resultant velocity. Okay. This one velocity is positive, means it's going upward. This one is going upward. That means the finally is like that. Finally is our Vx is also positive. Yeah, our Vx is also positive. Okay, our Vy also positive. That means our direction, you see the direction. You see the direction. The Vx is positive, Vy is positive. Vx is to the right, Vy is upward, isn't it? So that's Vx is positive, Vy also positive. So must write down the direction. So our Vx, okay, this is our Vx. Our Vx is positive. Our Vy also positive. So this is our resultant. Find the V, and then find the angle theta. Okay. So what's the answer? Yeah. What do we do? Find the magnitude by using Pythagoras theorem, which is the Vx square plus the Vy square. Okay. Just take the Vx here. Okay. Maybe I just substitute the value here. Yeah. Sorry. Vx is this. Vx is this. Vx is positive 1.5 exponent 7 square plus the Vy. Vy is this one. Vy is this one. 2.81 exponent 6 square. So square root them. So what do we get finally? What do we get? We get 1.53 exponent 7. That's it. Meter per second. That's our magnitude of the velocity. Is it magnitude enough? No. The question asks for velocity. Velocity is a vector. It's a vector. That means vector you need to give both magnitude and direction. If you don't give the direction, you lose marks. Determine the velocity. Velocity means you need to give both magnitude and direction. No direction, you lose 1 marks. So you need to give direction also using the tangent theta. Okay? So tangent theta is equal to using the Vy over Vx modulus. Okay? A modulus, so that we want to make all positive value. Okay? So Vy, what is Vy? Vy is 2.81 exponent 6. Vx is 1.5 exponent 7. Just take the value from here, and then you use antitangent. Remember, your theta need to be antitangent. Vy over Vx. Okay. Remember, use degree. Yeah, your calculator need to set the degree, not radian. Then your theta will get the value of 10.61 degree. It is look at here, it is above the positive x-axis. Above the positive x-axis. Yeah, above positive x-axis, or positive x direction. So that's our direction. Okay. The magnitude and direction of the final velocity emerging from the plate. Okay, so that's all for this question. Thank you for watching. Stay tuned for upcoming videos.